Dr. Rajpal Yadav, scientist from the WHO headquarters, Geneva. Dr. Manju Rahi from the ICMR headquarters. My colleagues in this hall, all the officers in charge of the NIMR field units who have joined online, and all dear friends who have joined online. I welcome you all to this special lecture in the lecture series being organized by MERA-India, ICMR and National Institute of Malaria Research. I request Dr. Manju Rai to introduce sir.
Right. Thank you, Dr. Anoop, for welcoming sir and myself. And I am extremely and personally thankful and deep gratitude to Dr. Rajpal Yadav for consenting and agreeing generously to come here physically to deliver this lecture under MERA-India. And him being I feel it's a special occasion for NMR to hear him directly, because we have been having online lecture series, but hearing him directly about the topic is today novel tools for vector control and surveillance it takes a special importance in today's era where we talk about malaria elimination, and directly hearing from WHO and his expertise and domain expertise of entomology and vector control tools, and he has that vast experience and expertise on it. It will be extremely beneficial for the community, not only of malaria, but in general about vector-borne diseases as well. And sir, I would like to tell you that we have online participants from all our field stations and many other non-ICMR organizations who join this lecture series. So we take this as an occasion to connect the dots with all researchers across the country. And this lecture would be available online on the MERA-India portal. Okay. So, but I'll just give a brief about him to the people who are new to this area, or what we'll be talking about. Dr. Rajpal Singh Yadav is a public health entomologist and a vector control specialist with nearly 37 years of global professional experience in the field of vector-borne diseases. He currently chairs the WHO Joint Action Group on the implementation of global vector control response and heads the pesticide management program in the Department of Control of Neglected Tropical Diseases at WHO Geneva. Previously, he headed the WHO Pesticide Evaluation Scheme, called short in HOPUS, from 2009 to 2017, and coordinated trials of vector control products with several research institutions and strengthened their capacity. He has facilitated development of several WHO normative guidelines for product testing, pesticide management, and vector surveillance and control. During 1984 to 2008, Dr. Yadav had occupied research positions at NIMR of Indian Council of Medical Research, the last position being Senior Deputy Director. He had established a field center of NMR in Eastern India, Rourkela in Odisha, and headed another one in Nadiad, Gujarat, which is also currently going on, from 1995 to 2008. There he conducted and guided research on the vector biology and integrated control of malaria, arboviral diseases, filariasis, and Japanese encephalitis in the forested, urban, industrial, and agricultural ecosystems. He was deeply involved in supporting the National Vector-Borne Disease Control Program, training entomologists and public health personnel on the integrated vector management and disease outbreak containment. He was a short-term staff at the WHO regional offices in New Delhi and KRO and at WHO headquarters on several occasions between 1991 and 2007. Dr. Yadav has received a number of honors and awards and published over 110 scientific papers in national and international journals. And I'm personally and professionally deeply thankful to sir for personally coming here for this lecture today. Over to you, sir.
Thank you, Dr. Manjurai, and good morning, all of you. Thank you, Dr. Anoop Anvikar and to Dr. Manjurai for inviting me to this lecture on new tools for surveillance and vector control. I feel very much at home at NIMR, which this being my parent institution, where from I grew up, and I'm today working with WHO for the last 14 years. I'm particularly interested to share the new experiences and new developments in pesticide management as well as on the vector control needs of the vector-borne disease control program. In today's lecture, I will restrict to new tools and I will tell you why we need those tools. So can I have the first slide? Okay, thank you so much. So because this is the MERA series lecture, so I will just restrict to only malaria. Otherwise, of course, new tools are being developed and are being needed for other vector-borne diseases control also. But in this particular lecture, I will focus on malaria tools. So that is why I just said new tools for malaria vector surveillance and control. So, all right. This slide shows the distribution of arthropod-borne diseases across WHO regions. So there are 6 regions all over the world of WHO. Each region is shown with a different color. And in this slide, I have shown different major arthropod-borne diseases in each region. So in particularly, I have highlighted malaria in the list of diseases of each region. And as you can see that except for the European region shown in blue color, all other regions have malaria as a major vector-borne disease. And that shows the importance that malaria is still a major problem all over the world in terms of the public health. 9 major vector-borne diseases occupy almost more than 80% of the world's population, which is at risk of at least one major vector-borne disease. And if you take 2 diseases, then more than 50% population is at risk of 2 or more diseases. And these 9 diseases are listed here in this slide on left side, but malaria is of course among the one of the major diseases in this list of 9 diseases. Now, as you can see on right hand side in this photo, which is that most of the southern part of the globe, which is the tropical part of the world, is endemic with major diseases, and darker the color means there are more diseases prevalent in that region. So India is the most dark color in blue, and you can see that it has several diseases, so which includes malaria, dengue, lymphatic filariasis, leishmaniasis, JE. These are major diseases. Also, to some extent, we had previously also onchocerciasis, but it is no longer there. Sorry, schistosomiasis, which is no longer there. And so other diseases, which is Chagas disease, is found in American region. HAT and onco are mainly African diseases. In 2022, the World Malaria Report actually showed that from this is the trend from the year 2000, and it shows that malaria incidence is declining slowly, and it has declined in the last 2 decades in terms of the incidence of cases per 1,000 population at risk per year. The other 2 graphs down below are the trends of malaria incidence and death in Southeast Asia. And generally it is showing that there is also a decline of the incidence of malaria in the Southeast Asia region. But if you look at the tail end of the cases, which is around 2021, that is the year before last and last year, there was slight increase in the incidence of malaria both at global level as well as in Southeast Asia region. And this is because of the problem of access to intervention tools. So all the decline that you have seen from 2000 to 2015 primarily was because of the core interventions that were applied at global level. So the 3 core interventions against malaria included insecticide treated nets. The color is shown in green in the bars. The second intervention was indoor residual spraying, which is shown in violet color. These are the 2 vector control interventions, which actually accounted for nearly 37% reduction in the incidence of malaria and 60% of malaria deaths. And the other third core intervention was the artemisinin combination therapy, which is ACT. So these 3 interventions together brought down the incidence of malaria drastically. And this graph shows the number of cases averted and you can see that in almost 15 years, the number of cases averted was being increased. So that means there was tremendous amount of impact of the disease. But if you go back to this previous slide, then after 2015, next 2-3 years was still there was a downward trend in the incidence of malaria, but in the tail end there was a slight increase, as I said before, which is because the insecticide treated nets, as it is shown in this picture, were the major driver of reduction in the incidence of malaria. And as the number of bed nets distributed globally decreased because of the low funding given by the donor agencies and by the allocation of bed nets in the countries, there was increase in the number of cases and deaths in the last 2-3 years. This shows that how important is vector control in reducing the problem of vector-borne diseases. And particularly these tools, when it comes to vectors, the new tools would improve efficacy, because insecticide resistance has reduced efficacy of the existing tools in many areas. So in order to improve efficacy, we need to introduce new tools where resistance has become a major problem. We also need to increase cost effectiveness, because when you introduce new tools, these tools cannot be costly, that the programs cannot afford them. Therefore, new tools should be affordable in terms of their prices. And also new tools are required to improve human and environmental safety. So for example, DDT is the insecticide which actually was responsible for reducing incidence of malaria in the 50s and 60s. But then there were lots of concerns around human and environmental safety against DDT. So gradually the use of DDT has been eliminated. And this is the reason that new tools should be the ones that have high human and environmental safety profile. At the same time, we also need new tools for improving surveillance of vector-borne diseases, and that is why this is the fourth element that I listed in this slide. Now, WHO's position on new tools is very clear, which is that WHO's legitimacy and technical authority lie in its rigorous adherence to systematic use of evidence. So in order to change WHO policies or build WHO policies, we need to have good rigorous evidence on new tools. And this was the decision of the 12th our WHO's global program of work. So this was identified that we would need new tools because of these reasons in order to build new policies. Without evidence, we cannot develop policies, because policies are evidence informed or evidence based. And in order to develop new tools, the stakeholders needed guidance, because people do not know what kind of data would be needed by WHO in terms of developing new tools. Therefore, in 2013, a vector control advisory group on new tools was set up in order to provide guidance to manufacturers or anybody who is interested in developing new tools. So suppose you have a plant extract which has a larvicidal efficacy, or you have a chemical that may have application on treatment of nets or of indoor residual spraying or space spraying. How do you assess it? What kind of data would be needed? What kind of safety profile would be needed? What kind of specifications data would be needed? So in order to assess these people, this vector control advisory group, or in short VCAG, was set up as a guidance agency to which people can go and they can seek advice on the various steps needed for developing tools out of that new product. So in 2017, WHO has adopted global vector control response as the global strategy for reducing the burden and threat of vector-borne diseases. And in these tools, in this approach, actually new tools is an important element. And if you look at the dark blue foundations, which is the on bottom side of this graph, then there is the lowest foundation, the lowest blue bar shows that there is a need for research. And research brings in the new tools which is here, because you need tools to improve the efficacy, and to scale up those tools you need resources. So basically this global vector control response actually drives different aspects of actions, and in these actions the tools to control vectors are an important element. At the same time, WHO has been giving guidance and support to stakeholders and to member states and to whoever needs the guidance. And these guidance can be of various types. So, for example, guidance for trial design. If you want to test a product in field, what kind of trial design would you use which is acceptable by the international community? And what would be the product evaluation pathway? So I will briefly tell you about the pathway in the following slide, but basically the WHO's guidance is both on trial design and pathway to follow. We are at the same time also developing several good laboratory practice or GLP compliant product testing laboratories. So in India, VCRC Pondicherry has been certified as a GLP laboratory only 3 months back. NIMR is also being strengthened by us, and in here in this center in Delhi, the center has been assessed for GLP compliance once, and once it meets all the requirements, then it will be certified to GLP. Now GLP is a system that is being followed for drug development, vaccine, and other interventions globally and also in India, because GLP system ensures high quality data which are reproducible and traceable. Traceability is an important thing. If you do an experiment, and if I come back to you after 1 year, you may not show me raw data. So how do I believe that the data that you are presenting in your report or in your research paper actually was generated? Or is it a fictitious data which was written on the table? So the GLP actually ensures that, because all the data that are generated on day-to-day basis in a GLP system will be recorded and will be filed, and there is a traceability that even after 5, 10, 15 years, if I come back to NIMR and say, oh, you did this experiment, show me the data. So the data are there. So that is traceability. And the tests that you do on day-to-day basis will also be recorded. So this way, the GLP system is the foolproof system that you cannot present any data that were not really generated. The system is so strong that even if you have entered some data in the register and you found there is an error, you will have to strike it and then sign it and enter new data to show that actually there was an error and I have corrected it. So that means you can see the traceability, how data was changed, what to talk of modifying it. So therefore, GLP compliant system has become very popular all over the world for vector control also, and we have so far certified 6 labs by WHO, and there are 3 more labs in Africa which are certified by our partners. In the WHO Vector Control Advisory Group, which is to advise on new tools, we have been assisting the manufacturers for evaluation of active ingredients with unrelated modes of actions of insecticides. We are also helping the manufacturers for innovative non-insecticidal products, for example, genetically modified mosquitoes where insecticide is not involved, or vector surveillance tools. On right hand side, there are 2 documents. The blue document actually is the document that sets the norms, standards, and procedures for development of WHO recommendations for vector control. This is an excellent tool. You must download it from the WHO website and look at it, how the norms and standards are required to develop strong evidence against for vector control products. At the same time, we have also recently in 2021 developed guidance on non-inferiority trials of insecticide-treated nets. So tomorrow, if you develop a product that you claim that this insecticide-treated net is very effective against malaria, you need to show the results against a gold standard or some product that is already available, and then you will show that my Y product is better than X product. So then how would you do that? Then you will have to plan non-inferiority trials, and non-inferiority trials in medical field for drugs and vaccines are well known.
Yes.
In vector control, they are not. We are actually first time people telling people that you should now plan non-inferiority trials to show that my new net is not inferior to the existing one. So this is the trial design that will actually generate data which is then scientifically internationally accepted. And this trial is for not only ITNs, but this guidance is also for products that are applied indoors for treatment for control of malaria. So this document actually is the first document that defines on the data requirement and what protocol scientists should do if they were to do a non-inferiority trial with an ITN or IRS product. Now I was talking about the pathway for evaluation of new tools, and this is the system in 2013 we started, and it is something like this, that if a manufacturer comes with a product, that product may be just an idea. The manufacturer thinks that I will develop a product around this idea. They can always come back to this group for seeking advice on how that idea can be converted into a usable product. But if there is a product that they have already worked on and developed, so they will come first to the vector control advisory group with an initial request that I want to submit my request to you for evaluation of my product. So the first time their application will be assessed by a pre-submission coordination committee. And this committee constitutes people from NTD, pre-qualification, and my department of and Global Malaria Program. So this committee then will decide which way this product should be evaluated. So there are two pathways. One pathway is that the products with a policy recommendation, and the other pathway is the products without a policy recommendation. Now, what is a policy recommendation? These policy recommendations is the recommendation which is based on some historical or previous WHO trials showing the epidemiological impact of the product on the disease. So, for example, DDT was being spread indoor for control of malaria because long back people had shown that spraying DDT indoor can reduce the incidence of malaria and not just of vectors. So here the difference is that a policy recommendation is the recommendation which is based on epidemiological trials and not merely on the impact on mosquitoes. So that means that all the categories that have a policy recommendation based on epidemiological evaluation of the intervention, then this is the pathway. So the people will submit their application, we will review the pathway, we will then ask them to submit safety data, efficacy data, quality data, and based on that the WHO will assess all these data and pre-qualify a product for further use for vector control or for disease control. But if a product had no policy recommendation, so for example genetically modified mosquitoes, nobody has so far shown impact of genetically modified intervention for control of malaria or any other disease. So that means you must design a trial that will generate epidemiological data. And this is what we mean by a product class without a WHO policy recommendation. So you have to generate epidemiological and entomological data apart from the safety, quality, and efficacy data against mosquitoes, that the four together will be considered a dossier, and then once assessed and found to be showing impact on the disease transmission, then this new tool will be pre-qualified and recommended by WHO for control of a disease. So in the second pathway comes several interventions like special repellents, which I will show you in subsequent slides, couple of those interventions that will fall into this category. The other category is straightforward. You are aware of space spray products, larvicide products, IRS products that historical were shown to have impact on disease, and therefore anything within those categories will not go in the second category, they will go in this regular pathway. Now in the first pathway, which is the pathway where epidemiological impact has already been shown, there are several products that WHO has already pre-qualified, and these includes insecticide treated nets, and these are different type of insecticide treated nets with different insecticides in them. Now a couple of them include nets which have a PBO apart from a pyrethroid, or a compound called pyriproxyfen, which is an insect growth regulator or juvenile hormone mimic, or there are nets that have PBO and pyrethroid. So those nets that have pyriproxyfen or chlorphenaphyr, these are the two nets against which epidemiological impact has not been shown. They have been pre-qualified as insecticide treated nets, but they are not yet pre-qualified for introduction for control of disease. All other nets have been pre-qualified for control of the disease because these new nets with a new molecule called chlorphenaphyr or pyriproxyfen, these are undergoing epidemiological trials, and once the trial data are available, they will be then pre-qualified for actual deployment for control of the disease. Right now, they have only interim or conditional pre-qualification, which is that they may undergo further trials until more data are available that shows that these nets would actually impact on the control of malaria. This is a list of insecticides for indoor residual spraying, that is spraying in houses for control of malaria. And this also has several new kind of compounds, so pyrethroids, neonicotinoids. Only 3-4 days ago, we pre-qualified a new insecticide in a new class called metadiamides. And in this, the new product is broflanonite, which is a new insecticide class. You may be hearing it for the first time because this is the insecticide that has been pre-qualified only 3-4 days ago by WHO. So in this list, there are several insecticides which have been tested for epidemiological impact, and therefore they were pre-qualified for control of malaria, and they can be deployed for actually in under operational conditions. Now, in this list, except for DDT, which has not been pre-qualified by WHO, all other compounds have been pre-qualified, and DDT has not been pre-qualified because the only manufacturer is Hindustan Insecticide Limited in our own country, but they don't own human risk assessment or environmental risk assessment data, and WHO needs all the data. So HIL's data are missing because DDT they have been using or were registered was based on somebody else's human risk assessment data historically. But now if they need to pre-qualify for WHO's use, WHO will ask three data: efficacy data, quality data, and risk data. And this company HIL does not have risk data. Therefore, they could not submit application to WHO. So while Government of India allowed manufacture of DDT and use and export, in WHO's list, this is not pre-qualified. So that means it is India's decision to manufacture and sell it, but WHO does not support the product manufactured by HIL. Although WHO still have a recommendation that DDT can control malaria in certain situations, but there is no manufacturer which has actually produced a WHO pre-qualified DDT. This is the list of larvicides for control of Anopheles larvae. And once again, it has several classes of compounds. So the top one include bacterial larvicides. And then there are insect growth regulators or chitin inhibitors. And there are organophosphates and spinogens. So there are several different type of class groups. Most important of this list, although you may be all aware of the larvicides, those who are involved in larviciding for control of Anopheles, in urban areas where Anopheles stephensi primarily is the vector of malaria, where larviciding can be effective, because in the rural areas, larviciding is not a feasible intervention because of the logistics required, and because there are millions and millions of water bodies which cannot be treated with larvae under operational conditions. Therefore, larviciding is a key intervention in urban areas where the larval habitats are few, fixed, and findable, and can be approached for treatment with larvae. But in this particular category, I want to highlight one particular product called Sumilar 2MR or pyriproxyfen 2MR. This is a plastic disc of just 2-inch diameter, and this incorporates pyriproxyfen as the larvicide. If you introduce this disc at the rate of one disc every 40 liter of water body or container, then this will keep the container free of Aedes and Anopheles stephensi breeding for almost 6 months. And this is an excellent tool for control of Aedes mosquitoes in urban areas, and particularly in desert coolers, where in India during summers people actually use the coolers, and then just before rains, when they don't need the coolers start breeding for Aedes and Anopheles stephensi mosquitoes and become the permanent breeding ground for next 3-4 months during the monsoon season. So this type of intervention can be very effective. We did this trial in a couple of countries, including in Chennai, and we recommended this product some 6-7 years ago, but this has not yet been registered in India. In spite of that, the trial was done in India. So these are the problems that in the previous 2 slides also I have shown several tools which have been pre-qualified by WHO but are yet to be registered in our country for use. So let me go back and show you once again that in this group there is a product called primifosmethyl. This is an organophosphate compound, but then this is very effective against the resistant mosquitoes. We have this new compound clothianidin and clothianidin will deltamethrin. This is a neonicotinoid compound which is against for resistance management against those mosquitoes that are resistant to pyrethroids. And as I said that only 3-4 days we pre-qualified a new class of compound which can be effective as long as 9 months of single treatment. So these are the new type of compounds which are the alternative compounds. In case you have resistance in the country, you have alternatives available with you, but then they need to be registered in the country. And for registration, whatever is the requirement of the Central Insecticide Board in India in terms of data, whether they need trial data or safety data or efficacy data, whether they need to be generated in India with 1 trial or 2 trials or 3 trials, this needs to be looked at, and particularly we need to streamline the requirement of data for registration. So many times we have seen that WHO did trials with at least 1 site in India, but still our registration requirement is that they would need 3 more trials in the country, which is therefore unnecessary requirement in terms of additional data and the cost and the time to the country. So suppose tomorrow there is an outbreak of malaria in pyrethroid resistant areas, what will you do? You don't have any new replacement compound, whereas we have a battery of products that are available which are recommended by WHO. And so similar, the larvicides, we don't have registration of some of these compounds, particularly like spinogenes are I think now I understand that some trial is going on for spinogenes for larviciding in urban areas. Now, I will come back now to the new tools that are being developed or being evaluated by WHO. So in this case, I have just put 2 products these are insecticide treated nets with chemicals with either a single compound or a combination of compounds, and in this case both have 2 compounds. So the first one intervention class is the insecticide treated nets that are designed to kill host seeking insecticide resistant mosquitoes. So if there was resistance to pyrethroids, for example, in some area in India where you want to eliminate malaria, then this is the product that could serve as an alternative in the future. This product is called Intercept G2, and it has pyrethroid, it has a alpha cypermethrin as a active ingredient, plus chlorphenapyr as a new class or with a compound with a new mode of action. And this product was pre-qualified after WHO Pesticide evaluation as a product, but we are still awaiting. The WHO was submitted data from epidemiological trials, and these trials were found to be acceptable. So currently WHO is evaluating the data in order to develop a formal recommendation for this product in terms of its use for control of malaria in areas where pyrethroid resistance is present. So this is a new compound, a new net that would be an alternative product. The second product is a Royal Guard long-lasting net which contains a pyrethroid, deltamethrin, and pyriproxyfen, which is a juvenile hormone mimic compound. So this is basically stopping the growth of the mosquitoes once they get this insecticide. Once again, this is a different insecticide class. So this class means killing host-seeking insecticide-resistant mosquitoes, but this is to sterilize or reduce the fecundity and host seeking fecundity fertility of host seeking insecticide resistant mosquitoes. Both tools are against resistant mosquitoes, but this one is to kill and this one to sterilize or reduce the fecundity and fertility. So both have a different mode of action and both have different insecticide compounds. That's the second compound. Now the second compound is second net is under review currently, and more epidemiological trial data are needed. If the trial data shows that this Royal Guard net can reduce the incidence of malaria or transmission of malaria, then WHO will pre-qualify it as an intervention that can be deployed in areas where mosquitoes are resistant to pyrethroids. So this is the first category of malaria focused tools, which is insecticide treated nets. The second category is the third category rather. I showed the two interventions in the previous slide. The third one is a special repellent. Now special repellents are different from a regular repellent. You must have used or at least seen using people some oils or creams or vaporizers on the skin, or the mats or coils in houses, which are actually repellents. So what is the difference between a regular repellent or a skin repellent and a special repellent? A skin applied repellent actually will prevent biting of mosquitoes or will kill them when coming in contact with the insecticide. But a special repellent will actually drive away insecticide mosquitoes from the closed enclosures, because the insecticide is in the air. Its action is in the air. So as soon as a mosquito enters a room and it notices that there are fumes of chemicals in the air, it will try to escape through the window or open doors or whatever crevices in the room, particularly in rural areas or urban areas where lots of open doors or windows would be present. So this basically is the device which will keep the space free of mosquitoes. That is why it is called special repellent. And in this case, there is a compound called transfluthrin, which is a pyrethroid, which is emanated from a particular wick or a bottle, and these fumes are present in the room, so they drive away mosquitoes. But then the epidemiological trial data are awaited. People are doing lots of trials in different parts of the world to show that using this device in large number of homes in a village or a community can actually impact on the incidence of malaria, because an epidemiological trial will be a large scale trial where several houses will have to be treated this way or will be provided with such a device, and then this will show mass impact or on the vectors and therefore the incidence of malaria. So this new intervention is undergoing trials and evaluation. The fourth category is attractive target sugar beds. You may know that both males and female mosquitoes need sugar on day-to-day survival. Blood meal, if the females get, they will produce eggs. But if they don't get a blood meal, they will try to seek sugar from some sources in the nature, so flowers or other plants or fruits from wherever they can find. And therefore, in this particular intervention, the manufacturer has developed a device. That device has plant-based sugars like fruit sugars or flower sugars, and these sugars will attract mosquitoes which are placed now in this device, that the anopheles that seek blood sugar will come to that device because it senses that there is sugar in this device, and then they will go there, and in the sugar is lacerated insecticides. That means the sugar is coated with a killing agent. So mosquitoes will absorb or will take the sugar. Along with that, it will also ingest a toxicant, an insecticide, and then they will get killed. So how it is deployed is that they are deployed as a bait station. So bait station is something like this. For example, there is a bait. So you apply insecticide with sugar on this seat and just put it in front of your house or under the tree or some places. So mosquito will get attracted to this bait station because they find that there is sugar in it. They come, they take sugar, but along with that they also take a toxicant. And so the question is that how many bait would you then put? Because you need to put large number of baits in front of houses or in the villages, and that is the intervention that is being now evaluated. That what number of baits would you need, or how long a bait will work, and particularly whether this intervention will work around the year, or it may not work during the season when fruits and flowers are already there. For example, now in India, you will find flowers everywhere. So mosquitoes may find alternative sources of sugar. So why should they come to this bait station? So you have to really generate data around all these parameters in different seasons of the year in order to determine whether a bait station can be an effective intervention against malaria mosquitoes. The next intervention is genetic manipulation of vectors for disease control, or what we call as genetically modified mosquitoes. And there are two approaches, but in these approaches, the idea is to reduce the either the population of mosquitoes, or we alter the population of the mosquitoes in such a way that they do not transmit the disease. The first intervention is being tested against Anopheles gambiae in Africa. The second intervention is targeted for control of both falciparum and vivax malaria in different areas. By the clarification of this intervention is like this. The first one is population suppression, and this is by releasing male Anopheles gambiae in African countries where trial is being conducted. This is to disrupt the fertility of female mosquitoes and to distort the sex ratio, so that there will be a decrease in the number of female to male mosquitoes, and that will actually crash the transmission in the particular area. When we talk of alteration, in this case, male mosquitoes that have a altered engineered construct of genes is being introduced in the local population. This will then mate with the female and will therefore reduce the number of female mosquitoes in the areas. The idea is that in both approaches, there are mechanical changes in the gene construct of mosquitoes, and then they are being released in batches in the target areas. Now, this technology again is being tested, and we have yet to see a lot of data in terms of safety, applicability, and their effectiveness. And so these interventions are being planned further, and it may take several years before these interventions see a light of the day. The only some problems are like this, that once a changed gene is introduced into the population, you cannot call it back. It is a permanent introduction of the new gene into the system. So tomorrow, if you want to say that today I will stop this intervention, you cannot, because the gene is already introduced into the population, and it will stay there as long as the mosquitoes carrying those genes are there. So this has therefore some ethical issues, and this has some safety issues also. So all these will need to be tested before these interventions can be introduced into the programs, and it will undergo several trials and several evaluations before countries will agree to introduce this kind of intervention. If you recall, or some of you recall, around 1973, in Delhi, there was a genetically controlled mosquito unit, genetically modified mosquito unit, which had mastered the mass rearing of Culex mosquitoes for introduction in Delhi for control of diseases. But when the releases were being planned, at that time there was a rumor that this is an activity which is leading towards biological warfare in India, and therefore people stopped this trial. In the Indian Parliament, there was a big discussion, and the project was closed down, and therefore no more research was allowed for introduction of genetically modified mosquitoes in Delhi. And this is again we are coming back to the same technology after almost 50 years, that we are looking at the same technology now with Anopheles mosquitoes. So at that time, the entire project was stalled, and that is how became the genesis of NIMR and VCRC. Because the people who were working in the unit, one was Dr. Sarla Subbarao, T. Adak, and VP Sharma, they came to NIMR, and Rajgopalan and his team, they went to VCRC, Pondicherry, and we actually, this unit was split into two centers at that time. Unfortunately, probably it was a wrong decision, but then sometimes, science has some fallouts on the sidelines. Now, the other category of new tools is the repellent lure devices. So these are the devices in which case in the houses around the houses these devices are put. So this will have actually the device will contain two type of tools. The inside that there would be a chemical which will repel mosquitoes from houses and immediate surroundings. This is a push technology. That means it will not allow the mosquitoes to enter into houses or lay eggs around there. And there are other devices which are that will lure the mosquitoes. They will attract them into those devices, and they will then the mosquitoes will come in contact with some insecticide kept inside the device or trap, and this is called odor baited trap. So this is the push and pull technology which is also being tested by some manufacturers, and therefore is still to see whether these interventions will become operationally feasible. This is a seventh is the systemic insecticide or endoctocides. In this case, the insecticide or the chemical is introduced into the system. That means if you, as a human being, if you take this as a pill, or if you give this product to animals in their feed and they enter into their blood, then this insecticide or this chemical is present in the blood, and on that if mosquitoes bite or sandflies bites, because this technology is being tested for control of not only of anopheles but also of sandflies, mites, and ticks, that the chemical in the blood of humans or animals will kill the host that will absorb the blood, or that will take the blood. So in this case, this is a technology in which case the insecticide is available in the system of the target hosts, and by mass drug administration, the idea is that if the entire village everybody is given a ivermectin dose. In this case, for example, I have shown the example of ivermectin. If everybody in the village has ivermectin in their blood, and if sandflies come to bite them or anopheles come to bite them, ivermectin actually will kill the insect. So this is the technology which is an indirect intervention rather than directly applying the product on the in the insect. We are actually killing it via the feeding mode. Again, this technology is under test for both malaria. There is some progress with regard to sandfly control, which is in a much advanced stage now. And then the other intervention is housing modification. Some people are also uh, testing a technology called eave tubes. So suppose if this room has exits through which mosquitoes will exit during the daytime. So entry and exit traps are applied on the walls of the houses through which either mosquitoes will enter into the room or they will exit. And if there is a barrier as a netting which contains insecticide, so the mosquitoes will come in contact either entering or exiting with that net, and then they will come in contact and die. This technology is again being tested in some African countries where housing is a major problem. Most people do not have good quality housing. In our own countries, in tribal areas, for example, people don't have safe housing, so they have very open kind of ventilated houses. If this technology is tomorrow applied in routine for construction of new houses for poor people or underprivileged communities, then this technology probably may be useful in future for control of insects entering into the houses. The other device is vector traps for mosquito management. In this case, for example, in this vector trap, if you add a chemical, let's say pyriproxyfen, which is an insect growth regulator, mosquitoes will come, they will actually sit on the water body or the little water that is contained into the trap. They will lay eggs, but their legs will pick up also certain molecules of pyriproxyfen. So next time when they go to other water container or other device, they will release the pyriproxyfen into that new water body, and this is therefore called auto dissemination device. This is because they pick up insecticide from one device and introduce the insecticide into another device. So this is a technology that is again being used, and is very probably useful in certain specific situations where there are lots of breeding of mosquitoes in gardens or in orchards in villages or in cities where this type of devices can be very effective. Once again, this technology is being tested. But if you do not add insecticide, this can become a vector surveillance tool, because particularly for Anopheles stephensi and for Aedes aegypti, which are container breeding mosquitoes, you can monitor what percentage of mosquitoes are laying eggs and what is the impact of intervention. Suppose if you apply some space spray in a urban locality, and you want to know whether the Aedes aegypti population has gone down or not, so you can put some traps here and there, and you can monitor whether mosquitoes are laying eggs or not. If they are not laying, that means they must have died. So this can become an intervention tool uh, uh, as a surveillance tool. Okay, thank you. Now, apart from the insecticides or interventions, I wanted to also share some information about improved equipment for delivery of insecticides. So in this case, this is a usual hand compression sprayer, but a couple of years ago, we recommended that we introduce a control flow valve here. So the red device is a valve that will deliver the controlled amount of insecticide on walls, so that when the pressure in the tank goes down, because as you use the pump, the pressure will go down gradually. But after using this device, irrespective of the pressure going down, the amount of discharge will remain constant. So suppose if this tank can be emptied in about 12 minutes time after you pressurize it, so from minute 1 to 12, the amount of discharge this will give after using this device will remain same. Let's say around 550 milliliter of liquid per minute. If you don't use this device, what will happen? In the very first minute, the pump will spray like 1 liter per minute. And as the pressure goes down, maybe around 10th or 11th minute, it will only emit 100 milliliter per minute, because the pressure is no longer there. So by adding this device, this controls the pressure inside, and it only allows what is required to be sprayed. Therefore, this type of devices are very useful, improved tools for indoor residual spraying. Several 6-7 type of pumps have been pre-qualified or tested by us, and I have just shown just one pump and the handle of other one. We don't want to promote anybody's name, so in this case, for example, although there is a name here, but this is another type of pump, which is a plastic body pump. But in this case, the control device is inbuilt. In this case, you can detach and clean and attach. But in the other device, although this picture is not so clear from here, but there is a control device here. So these tools are very effective in terms of economizing the spray operations and improving the delivery of insecticide and efficacy of the interventions. Then we are also working on promoting the packaging of insecticides. So historically, you must have seen that DDT was being packaged in aluminum foils or containers. And if you want to use this powder, DDT powder, for example, you will cut the bag from top and then take out the powder and put it into a tank, add some water and spray. That means you are constantly at the risk of getting exposed to the powder, because when you cut and open and handle it, there is a chance that you may inhale something, your hands may be lacerated with the powder. But by using water soluble bags like tea bags, so in tea bags, when you put the tea bag, the tea goes out, but the bag does not dissolve. But in this case, the bag also dissolved. So this is a pre-packaged water soluble bag, in which case if you put this bag into the container, everything gets dissolved, because this product is actually cellulose, and this gets completely mixed with the water. So you just shake it and apply. So that means that the worker's hands are not coming in direct contact with the insecticide, and the worker need not weigh the insecticide in the field, because then they are pre-weighed packets. So you take one and add into one container, add water, shake it and use. When your container is empty, add another one, add water, shake it and use. So this way you are not actually exposing the spray operators and workers with the insecticide that otherwise were possible in the routine conventional packaging. So there are now some insecticides that are currently available in as water soluble bag formulations, and our recommendation is that more and more programs should adopt this technology in order to avoid the need of weighing insecticide in field, and in order to minimize the exposure of people in the field to the insecticides. Now coming to the other surveillance devices. So entomological surveillance is a key pillar of the global vector control response. And in this case, I would restrict myself to monitoring resistance in Anopheles mosquitoes. Monitoring resistance actually is a surveillance intervention, because you are, as part of surveillance, you monitor the mosquito populations, but you also monitor the presence of resistance in mosquito populations. So in this case, in 2022, that is last year, we revised and published a manual for monitoring insecticide resistance in Anopheles and Aedes and Culex mosquitoes. And in this manual, we have also explained what to do in case there is a resistance to manage the resistance. So in this new manual, we have updated the insecticide discriminating concentrations for both Anopheles and Aedes mosquitoes. A discriminating concentration is the concentration that kills 100% of the susceptible mosquitoes, and this is the tool that is used to monitor resistance in laboratory. So you put a paper coated with a concentration and expose mosquitoes and kill them. So this is, you routinely entomologists actually use these papers, but we did not have many insecticide concentrations in the past, and therefore in one of the multi-center trials we actually tested some 18 new compounds, and in this manual added these concentrations. That means now you can order paper of all those insecticides that were not previously available. So people can now buy insecticide and monitor resistance. We also added in this same manual a new WHO bottle bioassay, and I will little explain about it little later. So this is WHO bottle bioassay. WHO bottle bioassay was developed because we were unable to treat many insecticides on filter papers. So there is a list here. Look at transfluthrin, because this is a volatile compound. So although you can treat it on filter paper, but no sooner you treat it in a day or two, everything is gone, because it is a volatile compound. So treated paper is of no use. Take the case of pyrethrin. Again, this is the same story. So many of these compounds were either not suitable for treatment on filter paper, or they simply dissipate on the filter paper because of their high volatility. Therefore, we developed a bottle bioassay. And one of the centers which participated in the multi-center study was NIMR, Vaisali and Dr. Raghavendra were the partners. Also VCRC Pondicherry, Dr. Gunasekharan and Sri Ram, these were the collaborators. So we had 23 laboratories which participated in this trial with bottle bioassays. And now this is a new technology or new tool that can be used for monitoring resistance against insecticides that cannot be treated on filter paper. So many of these compounds are already recommended by WHO for use either in indoor residual spraying or treatment of nets or larviciding or spray spraying. But these tools, when used in the field, how could you monitor resistance when there were no papers available or no tools available? So this is to fill the gap that this bottle bioassay actually will be a useful tool and is now available for use by the programs. Now, based on the multi-center study, we have therefore expanded the list of the compounds, so you can look at it. A large number of compounds are available, and these compounds are for a tube test. The other compounds are WHO bottle bioassay. Similarly, on left-hand side column is the class groups. So you can see this list which is available in our manual, which I showed in the previous slide, that we have now specifically recommended the concentrations that can be used for treating papers or testing in bottles for monitoring resistance against different species in different parts of the world against various compounds. Now, those species that are not listed in this, you can still use the highest concentration in that group to test resistance, because there are many species which could not be included. Like Anopheles culis species in India is a major vector of malaria, but this is not listed here. So you can take you go to a particular class group like alpha cypermethrin. There are two concentrations, 0.05 and 0.3, and in this case, because Stephensii is already there, but in this case we recommend that the 0.3 would be the highest concentration that can be used to monitor resistance against Anopheles culis species. So this is how the manual gives the instructions and details of how to monitor resistance in species that are not listed in this list. We have also developed several standard operating procedures for doing tube tests and bottle bioassays, as well as how to impregnate insecticides on filter papers in bottles. And therefore, this is again a tool that is available for surveillance, that is for insecticide resistance surveillance against Anopheles, Culex, and Aedes mosquitoes. We have also recently developed similar procedures for sandflies, and we are currently doing a study on Culex. But because this is a MERA lecture, so I therefore eliminated non-malaria details from these slides, just kept the Anopheles details. But in the manual, you will find details on Aedes and sandflies and Culex also. So you can procure in susceptibility test kits from Malaysia, which is our facility where we produce and supply these test kits all over the world. We are currently also developing VCRC Pondicherry as the center for treatment of papers, impregnated papers, and supply within Southeast Asia, because many countries were facing problem of procuring papers from Malaysia, which is technically logistically is a problem. So VCRC Pondicherry and a center in Brazil would be additional centers for production of impregnated papers for supply for resistance monitoring. At the same time, WHO has started developing a system for collection and mapping of data. And so Global Malaria Program is hosting on their website a page where you can go and you look at the data available which are shared by the countries on insecticide resistance in Anopheles mosquitoes. Lots of data on Anopheles are available, but few data for Aedes and Culex are available. Therefore, these are the gaps that we generate more and more data, and we share with WHO, so that WHO will, through the regional database, it will go into the global database of WHO, and we also get, of course, occasionally scientific publications. We use it and we update our database. Many research centers also contribute to this database. The idea is that this database will be used for mapping out the risk of resistance against Anopheles mosquitoes. But we will have to also develop similar systems for Anopheles, for Aedes and Culex and sandflies. I also want to share that in many countries, advanced research is going on through semi-field efficacy test systems. So in India, we even do not have experimental huts except for one center, and we are trying hard to develop experimental huts in Gujarat, but these huts are not so popular and not available with many centers. But in Africa, for example, this is a picture from Tanzania, where there is a semi-field efficacy test system. This is long, this is a shed which has several partitions inside, where you can test different type of compounds as if there were many experimental huts within a larger hut. So these systems have been built by researchers in different countries to test different kind of novel insecticides and other modes of actions and other products And if in India, we need to develop similar systems. So look at this picture, for example. This is a hut within a hut. Okay. So if you introduce mosquitoes outside, and if you have a bait inside and also intervention inside, then there are traps, and you can then monitor completely under your control how many mosquitoes you release here, how many they entered into this hut, or how many you release inside and how many came out of the hut. So there are different kind of experiments that one can conduct under controlled conditions. So you release the product inside or outside, and you can monitor where the mosquitoes go and what is their behavior. So these experimental semi-field systems are being used for behavioral studies as well as for testing efficacy of different novel compounds. And now look at this similar picture, in which case these are there are baits sitting inside a mosquito net. In this case, this was an experimental hut, but this is a bait, in which case you can test special repellent or skin applied repellent, or a device which is placed inside which is emitting insecticide, and whether that device protects the people who is sitting inside as a bait. So lots of devices and lots of experiments can be conducted using the semi-field system, and this needs investment. You need a land, you need to build it, and you need to train your people to test the behavior of mosquitoes and new insecticide and new modes of actions. Finally, we have also, with the support of VCRC, developed a new guidance on vector surveillance and control at ports, airports, and ground crossings. As you may know, that mosquitoes enter across the international boundaries through the transportation mode, through ships or aircrafts or trucks, and therefore we develop a guidance on how to monitor mosquitoes across international borders. Thank you so much.
This is a very truly very informative and educative lecture. I mean, all of us were taking notes, and I have the relief that this PowerPoint presentation will be available. And each slide had contained so much of information for all of us. We thought that we are updated with the latest literature, and we know that new documents coming up. But so the nitty-gritty which you have told about each of the things is extremely informative. So there are a set of questions on the chat box, and then maybe we can also take questions from people within the room. I also have a couple of questions. So first we can take the questions which have come on the chat box, then maybe from the participants here.
Yeah, please read it for me. So
the first question is, what is the future of genetically modified mosquitoes in malaria control and elimination?
I think I address one by one rather than piling up. So the technology of genetically modified mosquitoes is a long way to go, because right now people are doing experimentations to see its effectiveness under controlled conditions, and then these technologies, before goes to the field, there will be many regulatory and ethical and safety aspects, as I said in my presentation, before this technology can be introduced. And one of the risks of this technology, of course, is that once this technology is introduced, or the modified genes are introduced in the mosquito population, they cannot be called back. Unlike Wolbachia, where you can stop it, but in this case you cannot. Once the gene is there in the system, as long as the mosquitoes carrying that gene are present, you cannot stop these changes. So suppose in a tribal area where lots of breeding is taking place and you introduce this mosquito, then it is out of hand. So people are looking at regulatory, safety, and efficacy aspects. And once that is done, then the manufacturers of this technology, they will then come to the WHO Vector Control Advisory Group on new tools with the data requirement or what progress they have made. And then therefore, once they have sufficient epidemiological impact, safety data, ethical data, and regulatory details available, WHO will regularly review those and then will make some recommendations on their use. But of course, meanwhile, if any country wants to go ahead on their own of evaluating this technology and want to introduce at limited or larger scale, they are free to do so. But what I'm speaking is about WHO's position that we will need lot of all this information before WHO can pre-qualify these as the innovative tools.
So this in continuation of this, which RIDL Aedes mosquito, but they have been released at 10 countries. So they have been through WHO or independent.
So IAEA, International Atomic Energy Agency, is our sister organization of the UN, and they have tested this technology against Aedes mosquitoes in certain isolated areas like island countries or limited areas where the mosquitoes cannot escape into the larger populations. And so they have shown some results. Some results have been seen with Wolbachia and the sterile insect technique. Sterile insect technique in agriculture is a long known technology. So potentially it has good scope. And with IAEA, WHO is also working together, not only just for public health but also for agriculture pest control. And it may be that that few years may be needed to generate required data, but this is a upcoming technology, and it can be controlled because the irradiated mosquitoes, how much you release that, and they will mate with the females and will crash the population. So this technology can be called back if you don't want to use it.
Next question is, if the region is fully saturated with LLIs, also two regular rounds of IRS has been conducted, but still the malaria cases arises from that area, then how to counter the situation to prevent the transmission?
Well, it's a complicated point that if the area is saturated with LLINs, then first you need to find out whether LLINs are still effective or not. WHO multi-center trial has shown that in areas with highly resistant Anopheles population, introduction or maintenance of high level of long-lasting insecticidal nets can still prevent malaria. This is because the nets also has a physical part. Okay, so they will prevent the biting of mosquitoes on the host sleeping inside. So therefore, mosquito nets act on two grounds. One is the physical prevention of biting, and other is the kill. Now, if your vector is fully resistant, which is the case, for example, there is a mosquito called Anopheles tiasale in West Africa, which has 1,000-fold resistant efficacy. That means it is completely resistant. The killing action will not be there of nets. So you need a net that has a alternative compound with a new mode of action. But in India, we have seen that resistance in Anopheles is of low degree, about less than 20%, which means that your bed nets, pyrethroid bed nets particularly, should still work. And if you introduce pyrethroid plus PBO net, then it will also improve their efficacy. So therefore it depends on where areas where LLIN is fully saturated. Why should you do IRS? You should do IRS only when you are sure that LLINs are not working. And in my view, this situation has not arisen in India at least. So you should not apply IRS, particularly because if this IRS is with the pyrethroid, then it is useless. So if you were to do IRS in these areas for some reason, then do it with a different mode of action. So for example, IRS with malathion, or IRS with primphosmethyl, or with the other compounds that I showed you. Although in my personal view, in India, we don't need to add IRS for LLIN areas, at least for now.
Actually, this is similar to the same question. There are some districts where DDT is completely, most of the district DDT is present. LLIN is being distributed. So this local health personnel asked, because what IRS should they do? Should they do this?
So Mike, again we are coming.
They are doing this alpha cybermethrin as IRS also, and they are using LLIN also.
So as long as you are maintaining high coverage of LLINs, that means nearly 80% of the people use nets, not just have net, but they should use net. So first of all, you increase the access of nets to all the people targeted in the targeted population. They use it. Then pyrethroid nets would still be effective in India, considering that resistance in Anopheles species is less than 20%. The frequency is not so high compared with West Africa, which is fully resistant. In East Africa, it is something like India, it is less than 30%. So bed nets are still effective in East Africa, but not pyrethroid bed nets are not effective in West Africa. In India, the data currently show that they should be effective technically because pyrethroid resistance is not so intense. So I'm therefore not sure why IRS should be introduced. But if you don't want to use ITN, then as an alternative, if you are doing IRS, then do it with a compound that is highly efficacious. So that means you will have resistance data before you make a decision. One cannot blindly change an intervention without having scientific evidence that that there is a control failure. And control failure situation has not arisen in India at least. So either use LLINs or use use IRS with a insecticide compound that is fully effective.
And the Northeast also that the species is also different. They don't rest the walls like Tyrus.
So then I yeah. So then control of outdoor transmission is a completely different epidemiological situation, because in that case we need different other interventions, and some of the technologies that I showed you that are being developed are actually keeping that in mind. So, for example, uh, push and pull technologies or attractive targeted sugar bait. These are the technologies people started developing, keeping the outdoor transmission in view. Dr. Kumar, you can, yeah.
Yeah. Thank you, Dr. Yadav and Mera. Fantastic lecture, knowledge packed, and I always enjoy your talk. Two quick points. I mean, these are just to, let the House know that HIL is going to stop manufacturing DDT by 2024. So it won't be available. I do not know whether they have a special arrangement for countries like South Africa for manufacturing for them. I'm not aware. So this is one comment. The second comment is that the handbook that you mentioned about the mosquito surveillance and control at ports and airports. You remember that I had written it in when I was in NIMR, not in VCRC. So that stands corrected about 6 years back, and now it's available in 11 languages. They have translated it and used all over the world. The third is the question. The question is that when you mentioned that the cases have started going up in the last 2 years, when you showed that they are rising a little bit. And last 2 years we had pandemic also, and the systems were paralyzed. So was it due to the surveillance and control out of gear during pandemic, or it can be attributed to only LLINs not being distributed as was done earlier?
So thank you, Dr. Kumar. Yeah, I stand corrected that actually this was the the document that you referred on, the ports and seaports, was drafted by Dr. Kumar, and I took VCRC synonymous with Dr. Ashwini Kumar. So I mentioned VCRC's name, but it was basically drafted by him, and then of course it has been translated in several languages and distributed all over the world for use by people. So that I stand corrected. Thank you very much for reminding that. Now regarding the case rise, during the COVID-19 situation, one would actually expect the cases to go down because of the breakdown in surveillance, but it did not. It rather showed increase, and this is primarily because there are two regions, and one region is that there was disruption in supply of LLINs. Earlier, we would need around 350 million or more of long-lasting nets by donors that were being given annually all over the world through donor channels for control of malaria, particularly in Africa. But maybe because of COVID-19 or other reasons, that the contribution to the procurement of bed nets went down, So much so, I think less than 250 million or even less of nets per year, and that is well known to have affected the prevention of malaria in those communities, and maybe the rise of or potentially maybe the rise of incidence of malaria in some of the countries. Whereas in many countries malaria has been eliminated, but in the high burden countries, 11 countries particularly, of which India is the 11th, and there are 10 more in Africa, this situation calls for increase in access to core interventions. So, core interventions are long lasting insecticidal nets, and where resistance has developed to pyrethroids, we need nets with alternative modes of action or nets with PBO or other technologies. But at the same time, what has also happened, and which people also believe, is that when primifos methyl was introduced in African countries, primifos methyl and the neonicotinoid clothionidins were introduced in those countries, their cost was much more than the pyrethroid. If your total budget available is fixed, let's say $100, so earlier you were able to buy pyrethroids 10 kilos, for example. But if you now want to buy primifos methyl or clothianidin, you are able to buy only 1 kilo. So what will happen? You will reduce the coverage of the intervention. So this has also happened in many countries where the changes were introduced, that they could not maintain the same level of coverage because of the costlier insecticide made available to them. And the donor money was not increased. As a result, the coverage went down. And these potentially are the main reasons why incidence of malaria went up in last 2-3 years. Once again, in 2022, there is some signs of hope.
Thank you.
Thank you so much, sir, for the question. And I feel there will be several questions in the chat box. Are there? Can you show the chat box questions?
So there is a question by Dr. Anil Makapati that if we have to get updated epidemiological information on malaria, what is the authentic source? The source is the World Malaria Report 2022 and the previous versions, because these are the data officially shared by member states to WHO, and that is the authentic source of data. All other data is not attributable to WHO, is not the authentic source from our point of view, but they may be there. But whatever data are shared by countries is the only authentic source, because they have been shared through official channels.
Then I'll ask a tricky question over lunch, sir. No? Not now.
Okay, sure. Yes.
Charu, we need to email all these questions to sir. So whenever he gets time, maybe he can reply back to them. Many must be duplicative. I could see genetic modified again has come. So
yeah, I think if it would be helpful if you can jot down into a group of questions, so that the similar questions are taken together. Then I will find time, because I am completely busy until 1st April.
So take your time, sir.
So I will take time after that.
Not a Dixit, your question.
Sir, so do we have molecular surveillance for the insecticide resistance, like PCR?
Yeah. So largely in the countries, resistance monitoring work is done by programs, and that is by tube test method. This is the phenotypic resistance. It's not molecular or biochemical. So you wouldn't get that data from the WHO website. If you go to the Global Malaria Program, there is a page called Threats Map, where we map regularly the presence of resistance in different countries in real time. You click a country and you get the data, but you don't get molecular data, because these are more research data. But they are very valuable, of course, in developing local strategies. But research data comes from research institutions. So
Dr. O.P. Singh is one of the most important persons, and I think such persons should be included in committees, at least for the malaria control, malaria. Their opinion should be.
So with regard to the inclusion, we don't invite anybody randomly. There is always a call for experts, and you are free to apply as a potential expert to our calls, where then the list is prepared, and I will tell you how the selection is done. So there are 6 regions. The first criteria is that we give geographical representation to all 6 regions. Okay. Then within the region, then we look at the expertise according to gender balance. So there has to be both genders represented in the group, and then this is how the decisions are made. Sometimes availability of expert is also important, because many times what happens is that if a urgent meeting is called and some people may not attend because of some reason, that is a different thing, but otherwise the usual constitution of committees is based on this criteria. So whether it is Dr. O.P. Singh or yourself or anybody, you are free to apply to the committees. But of course, the general understanding is that people who have greater experience would have greater chances of getting selected, because your CV will be evaluated as part of your application.
Yes, sir. So I think we can pose these questions, sir. I have 1 or 2 questions, and then maybe we can wind up, sir, if you have time and for right now for a quick question, sir. So there was one. I mean, I have several questions, but one particular slide had you were talking about spatial repellents and trial of these repellents in experimental huts. So in a country like India, and I was discussing with earlier with Dr. Ashwini Kumar previously also, and many other researchers. Now there is an ethical angle of placing human baits, exposing them to mosquitoes. Our ethical committees are not allowing it now. Earlier it was allowed and we could do these work and experiments. Now how to test the new repellents, what to do with it if the countries don't allow, despite assurances of having insurance against any disease or having protective layer or clothing that won't attract mosquitoes.
So when I was manager of the WHO Pesticide Evaluation Scheme, we did several trials in Koraput with VCRC in these experimental huts. People will actually sleep in the huts under nets which are torn with 8 holes in. Okay, and mosquitoes can freely enter the huts. They freely enter into the net also and can bite the local people. But there are 2 considerations that were being made at that time. So we would argue 2 things. One is that we will hire people from the local area, which means that their immune profile compared with a person who you bring from outside will be very similar to the local area. So you do not have disadvantage of using that person, because his immune profile is very much like the local population. He is from the local population. The other selection is that we give equal opportunities to both males and females to be selected as volunteers for these trials, except that we would not include children, pregnant women, and old people because of the physiological status of their own physiological status. Other than that, we will say that if this intervention was expected to be very problematic, then we can give prophylactic chemoprophylaxis to the person sleeping under those torn nets under the experimental huts. Or if by any chance people suffer from the disease, which is the target of that intervention, then the project will take care of the treatment of the person. Now, if you hire a person for trial of an insecticide treated net for control of malaria, and after 7 days this person is found to have TB, it is not related to malaria, then you are not responsible for that. You are only responsible for treatment for malaria. Or you can introduce the system of doing a rapid diagnostic test after a few days of the trial ends, or periodically if there are gaps in the trials. So there are many ways of managing the risk of the people. In the entomological collections, we manage like this, that previously, if I were to collect mosquitoes on a human bait, then people will sit with bare hands and feet, and I will simply collect mosquitoes landing on the body. There is a chance that the landing mosquito will actually also bite if the collector was ignorant. But now there is a new system, which is that you put up a mosquito net without insecticide, put the bait inside the mosquito net. That means now it is physically protected. Now put a light trap 1.5 meter above the mosquito net and collect mosquitoes here. So mosquitoes that are entering into the room because of the attraction by this bait are collected by the trap. This is proxy collection.
Right.
Proxy bait collection.
Human
landing collection as a proxy measure rather than actually collecting mosquitoes landing on the body of the person. So you can manage in different ways, but still if your committee is so strict that they will not allow any of this, you don't do the experiment. what can you do? What can you do? The point is that scientists must argue that your experiment will not put the volunteer on a great disadvantage.
So because to study biting rhythm and other, even the normal vector dynamic study requires human landing collections, and that's not being permitted. But the method you were telling that a physical barrier with a plain net and a trap may be a proxy measure.
Yes.
We will try that, sir.
Aspirators can also be used.
Sorry?
In the nets. Aspirators also can be used like similarly what we were doing for landing collection. So a person if is inside the net, then you can collect from the net.
Yeah, but if the mosquito come in contact with the person as a direct physical access, then the chance is that it may bite. So that is why putting these under baited traps, what we call as baited traps, this proxy method. A baited trap is a method, but then this needs to be validated against your local species. And in Rourkela, when I was the officer in charge, we did the actually human landing catches versus a baited trap collection, and with Anopheles fluviatilis we found very good correlation that although the number of mosquitoes trapped or biting a person will not be same, but the trend is same. So this way you can use this technology for monitoring the impact of intervention.
Sometimes carbon dioxide is also used for other carbon dioxide is also used as a attractant for human and
no, but I don't think that will become an intervention.
Yeah, carbon dioxide cannot be used for testing interventions. It can be only used for behavioral studies or collecting live mosquitoes for testing, let's say, instant resistance, or using that material for biochemical studies for resistance, because you need some live material. So those baited devices have other advantages, but not for monitoring interventions.
So I think we have come at the end of the session and end of the lecture. So we are extremely, extremely thankful to you for spending time on this and for a very beautiful lecture going through the journey of vector control tools, which are now, I mean, maybe shortly available, but they are in the pipeline and in the research. So we would like to express our thank you to you by giving this a small token. Rotanupan, will you hand in? Thank you.
Thank you so much. Thank you so much.
Thank you.
This is a beautiful gift.